Frostbite Theater presents Cold Cuts, no baloney.
Just science.
Now, what'll happen if a person were to touch it? Or maybe a better question is, should a person touch it? Well, maybe yes, maybe no. Do you guys know what voltage is? What does voltage measure? It's actually a measurement of energy per charge. Do you know how many volts are in a flashlight battery? One of those D cells? 1.5. Very good. How many volts in a 9-volt battery? 9. Yeah, that's why they call it a 9-volt battery. How many volts come out of the wall? About 120. How many volts on that? When that thing's running well, that's about 200,000. Okay, so think about this for a second. Can you safely touch a flashlight battery? Yeah. Can you safely touch a 9-volt battery? Yeah. Can you safely stick your finger in the outlet? No. So if you can't touch 120 volts, should a person touch 200,000? Probably not, but you want to see it anyway? That's what I was afraid of. So, first, before we do this, I know it's not on. But there is something I am on that I don't want to be. The ground. What's this? Stool made from? Which is an? I'm going to get on the stool. Not because I'm short, but because I want to get away from the ground. Or if I'm down here, the only insulation I have is whatever's in my shoe. Not that much. If I'm up here, I've got my shoe, and I have 9 inches of plastic? Something like that. Hopefully, it's enough insulation, the electrons won't flow through me and into the ground. They'll just gather on me. If they just gather on me, what should happen? What hair I have left should stand up. Yes. 3, 2, 1. Ah! Got it! Doesn't hurt. Anything happening? I'm hoping hair is doing something. But at any rate, I'm not dead, which is a good start. Right? Now, how many volts are on my left hand? How much is a bunch? About 200,000. What'll happen if I touch the dome with my right hand at the same time? Nothing. Why does nothing happen? How many volts in my left hand? 200,000. How many volts in my right hand? 200,000. What's the difference? There's no difference. Electricity flows from high voltage down to low voltage. If it's the same voltage, it doesn't move around. It's like having a bathtub full of water. If all the water is at one level, the water stays put. Have you ever seen birds land on the power lines? They don't get killed. Same reason. Both their feet are at one voltage. They might get a little bit puffy, but they don't get killed. Now, what would happen if instead of this dome, I touched the grounding dome with my right hand? How many volts would be in my left hand? 200,000. How many volts would be in my right hand? Ground is 0. Defined as 0. What's the difference? 200,000, that's like a waterfall. Okay, the electrons will flow from a high voltage down to a low voltage. In fact, if you listen carefully when I point at the dome, what's that sound? Yeah, those are electrons flying off my finger. You'll notice, watch my hair when I point. Why does my hair go down? Yeah, if the electrons are flying off my finger, they're not on my head to make my hair stand up. And you'll notice it also doesn't do it when I make a fist, but it does when I point. It turns out charges jump off of points easier than they jump off of rounded things. That's why these things are round, is to gather the charge. You know what a lightning rod is? What's a lightning rod? Pointy piece of metal. People think it's there to attract lightning. It's actually there to bleed charge away so lightning doesn't strike. In my pocket, I have that nail. It's like a lightning rod. If I let go of the point, if your ears are good, you can hear it whistling. If your eyes are good, you can see when I cover the point and I let go of the point, my hair moves up and down. Don't know if you can see it, but I can feel it. I can feel it moving. It's more obvious, though, instead of pointing at the audience, if I point here. Okay, so again, why is my hair going down? I'm losing electrons. The electrons are flying off the nail to the dome. And if I get it close enough, we can actually make a little spark that we can see better if Mr. Dave turns the lights off. A little spark. Lights back on. So that little spark tells you something. For there to be a spark there, the electrons have to come from the dome through me, out the nail to that dome. If electricity is flowing through me, why am I not dead? I'm not insulated. That's the ground. I'm touching the ground. I'm not disappointed, I'm just confused. Why am I not dead? Well, I mean, if you like, I can come down here. What's my hair doing? Nothing. Where are the electrons going? Through my feet into the ground. If I get up here, I block them. So electricity was flowing through me. Why am I not dead? Again, this is not a major disappointment on my part. But why am I not dead? Do you know what current is? Like in a river, what does current tell you? Yeah, which way and how much. Okay, which way is the water flowing and how much water is flowing. For electricity, what does current tell you? Which way and how much. Right, is this a high current or a low current? It's low. That's why I'm not dead. There's just not that much electricity flowing through me. If this were a high current, what would happen? Yeah, I die in kind of in a gross way. Have you ever cooked a hot dog in the microwave? Ever forget to poke holes? What happens if you don't poke holes? It blows up, right? Because the water inside changes to steam and it needs to get out somehow. Well, if this were a high current, the same thing would happen to me. My blood would boil, and I'd blow up all over the room, which would be an experiment you only do one time. It's also why you don't stick your finger in the outlet. Okay, even though the outlet's only 120 volts, it's a high current. And it's really the current that gets you, and not really the voltage. Now then, what'll happen to my hair if I let go of the dome? Stay up, mostly. How come? I'm insulated. I'm insulated. There's nowhere for the electrons to go except from the water vapor in the air. If I want to get rid of it quickly, what do I need to do? I need to step off. And as soon as I step off, I get a shock through my foot, and the electrons lead me that way. By the way, this is how a lightning rod works. Here's your thunderstorm. You have a lightning rod. You bleed off the charge, lightning doesn't strike. Your neighbor doesn't have a lightning rod. They get fried. You're fine, they're not. You're fine, they're not. So that's a little bit about charges and electricity, and again, it's why our machine works in the first place. Our machine